this is Jackie Cambridge. Welcome to one of our short videos to support your Nebosh certificate studies. So in this particular session, we're going to be looking at hand-arm vibration. So hand-arm vibration, it's a physical hazard because it involves an energy, and usually it's about something spinning around, and as it spins, we hold something into it and it pushes us back. So whatever's spinning tends to go slower, faster, depending on how much force we're exerting. So it's usually something spinning or something reciprocating or sliding. And we're holding a force and we're being pushed forwards and backwards. So we're going to have a look at hand-arm vibration. So can you think about any tools and equipment in your workplace or even at home where they might generate high levels of vibration that affect your hands and your arms? Obviously you can see pneumatic drill and breaker there in the picture. Can you think of any others? So we've got things like chainsaws, road breakers, as I've mentioned, hammer and pneumatic drills. You're exerting some force and it pushes you away. We've got handheld grinders and sanders, can generate high levels of vibration. But even at home, you might have a lawnmower or a strimmer even, that again generates high levels of vibration. And obviously from an occupational point of view, we're interested in people who are likely to be using this equipment more often than perhaps us just mowing our lawn every other week or using the strimmer occasionally. So vibration is a hazard. It has the potential to cause harm. It can cause a range of conditions, and those conditions can affect our blood, our nerves, our bones and our joints. So the blood circulatory system that it takes all the oxygen to all of our different organs, and the arteries send the oxygenated blood out, and then the veins send the deoxygenated blood back to the heart and the lungs. So at the end of our fingers we have capillaries, and they're where arteries and veins join together. And the capillaries are very, very narrow, and they allow the oxygen in the blood to go into the cells and the carbon dioxide to pass back into the blood and out. Because the capillaries at the ends of our fingers are some of the smallest capillaries that we've got, if we work with vibrating tools, those little capillaries get damaged and they die. So that means our fingertips lose their blood supply. So when we are working with vibration, it can cause a condition called vibration white finger, and that's because the little capillaries in the ends of our fingers die, and then the ends of your fingers don't get a blood supply, and if they don't get a blood supply, they're going to die. We've got nerves in our hands and our fingers, and again, subject to vibration, you can get senses like pins and needles. Nerves are what tell your brain what you're feeling or touching. If it's hot, it's cold, it's rough, etc. So again, vibration can not only lead to pins and needles, but it affects your sense of touch. You may not be able to feel if it's something that's rough or smooth. You may not be able to tell different types of coins, so you can lose your ability to touch things. And then from your bones and your joints, the vibration can affect the ability to grip and to have strength in your hands, open a bottle top, those sorts of things. So, and you can get some inflammation. So it can almost look like you've got rheumatoid arthritis, you get swollen joints. So we shouldn't underestimate the effects of vibration, okay? And those of you who are studying and have already had a look at noise, sometimes if you've got equipment that generates noise, which is handheld, it will quite often have vibration. And vice versa, if you've got equipment that's handheld that causes vibration, quite often you'll also have noise. So similar principles apply to noise and vibration. So control of vibration at work regulations are aiming to reduce the risks to our employees. They set exposure limits and action values. The action values are basically saying if your employees are exposed to this level, you must manage it. And the limit values are, right, no employee should be subject on a daily basis to this amount of vibration. So the exposure action value is 2.5 meters per second squared A8. It's as easy as that. We measure vibration, we measure the acceleration as it slows down and speeds up. So meters per second squared is a measure of acceleration. So, and the A8 is the frequencies of vibration that affect a human, and it's an 8-hour day. So this level is not a peak, it's not a one-off, it's the amount of vibration that an employee is subject to in a day. And if employees are subject to that amount or more, the regulations apply. And if they use lots of different tools, we have to calculate roughly how much exposure they've been subject to by each of those tools and estimate their daily dose. Their exposure limit value is 5 meters per second squared, again A8. So this is saying our daily dose, whatever equipment we're using, mustn't exceed this. Now that doesn't mean to say you could use a tool that generates 10 meters per second squared, but if you did, you could only use it for 4 hours. So if you double the dose, you must halve the time. So that's why you might have a chainsaw that generates 16 meters per second squared, but then there would be a limit on how long you could use it in a typical day. And again, that's outside of our realm in terms of measuring this, but to say these limits are there, and if you've got any manufacturer's instructions, they will be in there as well. But they give you the perfect readings. When people are really using equipment, it might vary. So if we think people are subject to the exposure action value, we do a suitable and sufficient risk assessment. What equipment are they using? How long are they using it for? Are they particularly vulnerable? Have they got any ill health conditions? And then we need to take steps to eliminate or control exposure to vibration. For information, these regulations include whole body vibration as well, but these limits are the hand-arm vibration limits. If people are subject to the EAV or above, they have to be subject to health surveillance. And that health surveillance may be actually keeping an eye themselves, but it could also be an occupational health nurse. And one of the things they do, they can test your feeling, your blood supply, they can look for any signs and symptoms, changes of colour, etc. And in terms of that health surveillance, it's trying to, if we can spot the problems early, we can do something to stop them becoming too bad. Any employee using equipment that causes hand-arm vibration, it's the usual information on how to use the equipment, on the signs and symptoms, instruction on how to keep your tools sharp so that then they reduce vibration levels, and training, how to use equipment safely, how to carry the task out safely. So we throw in the phrase information, instruction, training, but for this, it's really important that it's done correctly, because people need to take steps to reduce the injuries, the likelihood of injury to themselves, but the employer needs to make sure that it's actually been. So some examples. We've got these vibrating tools, we still need to use them. What can we do? If you buy a modern tool these days compared to the one you bought 5, 10, 15 or 20 years ago, it will have a lot of additional suppression and isolation built into it, so it's likely to generate less vibration in the first place. If you buy a chainsaw today, compare it to one you've had 20 years ago, it would generate far less vibration. Can we change the process? Instead of metal banging onto metal, can we have metal onto rubber, so that will reduce the vibration? Increase the speed or reduce the speed of the process, because if it's running smoothly, it vibrates less. Clothing and gloves, keep your hands warm. Now, please don't rely on anti-vibration gloves. They have some padding in, but they are not going to reduce vibration. If your hands are like this, a pair of gloves is not going to help. But what you really want to do is keep your body and your hands warm, because if your body and your hands are warm, your blood is circulating, and if your blood is circulating, that will help reduce the risk. If your hands and body are cold, the blood goes to your core organs, your hands, fingers and toes get cold, and then they are at greater risk. So keep your body dry and warm. Maintenance of equipment, lubricate, run things smoothly. They're going to generate less vibration. Regular breaks or changes of activity, not using the same tool for a long period of time. Isolation. So isolation mountings are basically isolation. If you've got something that's vibrating, putting rubber or cork so it's not banging onto it. Damping, again, things that are not very solid will vibrate. So if you make it stiffer or firmer or thicker, it won't vibrate as much, and then it will reduce the vibration. When people are not using the equipment, exercise their hands and fingers. It encourages the blood to flow. Things like chainsaws and other handheld equipment sometimes has heated handles, because heated handles encourages the blood to flow. And if your blood is flowing, it keeps your hands warm, it reduces the risk. So we can look at the equipment itself and its maintenance. We can look at how we use it. If a tool is meant to be held with two hands, hold it with two hands. If you only hold it with one, that hand is going to be taking all of the pressure and you're going to have a lot more vibration. But equally, it's about people exercising their hands, wearing the suitable personal protective equipment, and reporting if any equipment is not running smoothly, changing blades, making sure things are sharp, making sure things are tight. That will all help reduce the vibration. So that's a very quick potted tour around hand-arm vibration to support your Nebosh certificate studies. This is Jackie Cambridge. Thank you very much for watching.